Alrighty, parametric equations and conics study guide, problem number 1. First off, for all of these problems, we want to try and do all of these without a calculator. Secondly, pretty much for each of the problems, you basically want to do everything you can do, by which I mean you want to get the equation in rectangular mode and also in parametric form. You want to know where the foci are, where the vertices are, where the asymptotes are, what the equations are, the coordinates, and you want to be able to sketch a graph. You want to be able to do everything. So let's go ahead and get started. We are given the two vertices and two foci of a conic section, so it's either an ellipse or a hyperbola or a circle, but probably not a circle. So anytime I'm given a problem like this, I like to start to draw myself a sketch because I like to visualize things and that helps me. So I'm going to go ahead and plot the two vertices and the two foci. So let's think about what we know already. First off, we know this has to be a vertical conic section because all the vertices and foci are lined up vertically. Past that, we know that this has to be an ellipse since the foci are on the inside. And if we want, now we can go through and we can find the center of the ellipse by going halfway between our foci. Equivalently, also we could find it by going halfway between the vertices. Same exact thing, so let's go ahead and identify that. So for example, if you look at your two foci, one has a y value of -1, the other has a y value of -7, a distance of 6 between those 2 points. So go 3 down from the top foci or 3 up from the bottom foci and end up at the point -2, -4 for the center of this ellipse. That is useful to us because now we can figure out our A value, center to the vertex, and also our C value, which is the center to the focus. So figure it out going either direction, but let's go ahead and find those values. So C, the distance from the center to the foci, is 3, and if you can't remember A, B, and C, what's what, remember that C is the center to the foci, because the foci or focus has the C in it, so that's C. That's how I do it anyways. And then you know A is always going to be from your center to your vertex, so in this case that is 5. And remember, we have the equation that is almost like the Pythagorean theorem. It says c squared equals a squared minus b squared. So we can find the value of b, half of our semi-minor axis. If we substitute our values in, we get 9 by squaring 3 equals 25 by squaring 5 minus b squared. So if we rearrange that, we get b squared equals 25 minus 9. So b squared equals 16, and hence b equals 4. So now we can finish up this sketch because we know that half the semi-minor axis is 4, which means go to your center and go 4 to the right and 4 to the left to figure out those co-vertices. Let's go 1, 2, 3, 4. We're going to end up there. And 1, 2, 3, 4 in the other direction. We're going to end up about there. And we can sketch in this ellipse. That's not the best sketch I've ever done. Yours should look better because it's harder to do this on the iPad than it is to do it by hand. So at this point we know where our foci are, we know where our vertices are, we know our values for A, B, and C, so all that's left to do is write these two equations in rectangular form and also in parametric form. So remember, we are dealing with the equation of a vertical ellipse And so that is going to be y, already messed up, y minus k quantity squared over a squared, and a is with y because it's vertical, and remember a has to be bigger than b, so y minus k squared over a squared plus x minus h quantity squared over b squared equals 1. So substitute all of your values in. Y, and since our center is down at, what is that, 1, 2, 3, 4, it's at a y value of -4, we're going to get y plus 4 squared over a squared. A is 5, so you can just write it as 5 squared. I'm actually good with that. It looks better, I think, because you know what a is right away. Plus, parentheses, x plus 2 squared, because again we want to move that to the left 2, over b squared. B is 4, so over 4 squared equals 1. And now if we want to write this in parametric mode, x equals y equals, remember the Pythagorean identity, we can use that to get our parameterization quite quickly. It's going to be x equals b times the cosine of t, or theta, whatever you want to write, plus, minus 2. Okay, here's what I want to do. B equals cosine t plus h, and y equals a sine t plus k. Those are going to be our parameterizations. So when we substitute our values in, we're going to get x, and notice b is with x and a is with y, again because it's a vertical ellipse. So now substitute our values in. B is 4, so x equals 4 times the cosine of t, and since our h value is -2, we get -2. Notice in rectangular form the number is opposite, that +2, even though we want the value -2. But in parametric mode, it actually is that h value. And then finally, we're going to get 5 sine of t, and our y value is -4. So again, it's going to be -4. Now, the starting point of this parameterization is going to be right there, and our orientation is going to be counterclockwise. Remember, because x is with cosine and y is with sine. If you flipped it, if you had 4 sine t minus 2 for x and 5 cosine t minus 4 for y, our starting point would be up here, and our orientation would be that way. That's everything you might ever want to know about this ellipse. But also remember, we should define a t value, 0 less than or equal to t, less than or equal to 2 pi. Just one trip around the unit circle. Sweet!